today we will be discussing about the embedded system design, and the discussion will be more focused on the software design, so embedded software design. So we'll see how embedded systems are, and then how embedded software are designed together. So agenda for today's discussion is like we will define the embedded system first. What is the embedded system, how they are, and then we will see what the basic components, basic structure of embedded systems, the components of embedded systems, and then further we will go through the software architecture of the embedded systems and different tool chains used, and typical industrial process for the software design, embedded software designs, and then at last we'll see the future of the embedded systems as well. So this is the agenda that we'll follow for this session. Take you through the prerequisites. So prerequisites for the embedded system design is like one is to understand the different programming languages. It can be assembly, it can be C, C++, Rust. One needs to understand microcontroller concepts, the configuration, different types of microcontrollers, how those are configured, what all services they provide, how those are initialized. So one has to understand the microcontroller, why, what on things microcontroller come up with. The very vital part of the embedded system is the real-time operating system. One has to understand the concepts of operating system, and then the real-time operating system, what all services, what all facilities the RTOS provide to us. So that is very important. Knowledge of different communication protocols like I2C, SPI, CAN, LIN, FlexRay, USB, Bluetooth. There are a number of communication protocols. Those are there. One needs to understand all those communication protocols in details. One has to have a knowledge of electronics, and one needs to able one has to one must be able to read the schematics. So different schematics would be there, connection diagrams would be there, and one has to understand those. And again, the last thing would be like read the data sheets of maybe different components. Those are there in the embedded systems, and also of the microcontroller. So these are like some of the prerequisites. Some of these points we will deep dive today in the session, but otherwise one has to go through, or one needs to be well versed with this points. So moving ahead to the next slide, is like we will start with defining an embedded system. So what is an embedded system? So embedded system is basically a microprocessor or a microcontroller based system with hardware and software designed to perform a very dedicated function within a larger mechanical or electrical system. So it is so embedded system is a very specifically designed smart system that performs its operations, predefined operations, without or with very minimal manual intervention. So that is what is embedded system is. So every part of your life is now filled with embedded systems, embedded devices. You look at everywhere or any corner of your house, you will find some or other type of embedded devices. Those are there with you. So this is what roughly we can define an embedded system, what it is. So when we talk about an embedded systems, so we will have to understand like how its basic structure is. So the embedded systems basic structure consists of a sensor, an input sensor, then some signal conditioning. A sensor is to like sense some physical properties those are happening around in the environment. Then there will be some signal conditioning system. Then there will be this microcontroller, which will contain an application, also has configured inputs and outputs. Also, it will be giving us facilities of memory and time. I will discuss those parts in detail. And also it will have some communication interface. So a sensor with some signal conditioning, data coming to microcontroller with smart application running on top of it, takes some decisions, reads that data, takes decisions, and then drives some gives signal to output to drive something, some output devices connected through again some sort of signal conditioning. So the output can be some sort of display, some sort of alarm, an actuator, a motor. It can be anything. So you can just consider somewhere like say you you are sitting in a room and you have a motion sensor connected to your electric device. If you don't move the electric say light switches it off. So when you move your hand, it has a movement sensor with it. So if once you move your hand, your movement sensor will detect the sensing the movement. This It will sense the movement. It will it will process that signal. The controller within that will sense it, and then it will actuate the light signal again, which was switched off, assuming that no one is there in the room. So this is very basic example that I can talk of, just for you to connect to each block that we are discussing in this diagram. And then there is one more block yellow in the below part. You can see that external word. Now embedded systems are not just an embedded device that is lying in the corner of the room. It is now has been connected to cloud. It is like IoT is the new buzzword in the market. You would have heard it in your curriculum. So it is connected to a number of other devices as well. It is connected to cloud. Now this is like exchanging statistics, exchanging data. It is exchanging the diagnostics, prognostics. It is exchanging a lot of information. And that's why this has become an essential part of embedded system as well. So this is how we can say that if you see any embedded device, you can very well segregate those embedded devices in these boxes. So we'll now we will move to different components of this embedded system structure that we just looked upon. So the brain of this embedded system is the microcontroller. You would have heard 8-bit, 16-bit, 32-bit of microcontrollers in the market. There are a number of players who are manufacturing the microcontrollers. It's a Freescale, it's STM, Intel. So there are lot many silicon manufacturers available in the market. So the microcontroller, what exactly microcontroller is, how microcontroller is helping us to devise an embedded system. Microcontroller mainly is providing us three things. One is IOs, another thing is memory, and third thing is timing requirements. These three things are very vital apart from all other peripheral connections, ADCs, DSCs. There are many other things as well it is providing to us. But these things are very vital part of the embedded system that microcontroller is providing us. So apart from that, it has a mic, like say with this part, with these three things, we will have our application programming on top of it. Application programming, we'll see it in detail. So just to touch base upon it, it can have multiple you can write your application in many other languages, many multiple languages, and you can program it in on top of the microcontroller. IOs, memories, and timing requirements we are going to discuss in details in subsequent sections. Application programming also will take its slide in subsequently. Selection of microcontroller. So this is very important part when we think about how the microcontroller, which microcontroller should be selected. Because if you Google on if you put in like the microcontroller, you search for the microcontroller on Google, you will get thousands of microcontrollers available in the network. So which is the correct microcontroller that you should go ahead with? So it will need lot of research in that, but it will need basically what it needs is you should be understanding the underlying application, the underlying need or underlying functionalities that for which you are going to devise or design this embedded system. So you should be understanding this the application through and through, end to end, right from user interface to the output of the system. So you should be understanding it thoroughly, then you can be able to understand, or you will be, that is the first step that you can go for the benchmarking of the microcontroller or the selection of the microcontroller. So you will need to know how many IOs you need. Like say it can be like general purpose IO, it can be ADC, it can be frequency input, it can be PWM. There are a number of types of inputs there. So how many IOs you will need? So you should be able to chalk that down on the paper. You should be able to create your own design on the paper, and then you can be able to count those IOs those would be needed for you. You should be able to know like how many interfaces you will be requiring, what all interfaces you will be requiring. So you require UART. So how many UART you would require? Why it will be requiring? How many SPI interfaces you would be requiring? How many I2C channels you will be requiring? How many CAN channels you will be requiring? So these are like in hardware interfaces that you will be requiring to know to go for any decision. You must be knowing like the processing time. So timing requirements you must be knowing. That is where like the crystal will come into picture. You will understand if this microcontroller is sufficient to give my timing requirements, or fulfill my timing requirements. You should be knowing like if floating point mathematics is required, any DSP operations are required. So with this you will start building, or maybe filtering, you can say it to correctly, like you will start filtering out the microcontrollers. You need a floating DSP operations to on top DSP operations to be carried out. So that is where you can filter out many of the microcontrollers with that. What would be the power constraints that your microcontroller would be? What would be the environmental conditions? What will be the temperature it will be working on? Where will it be mounted? So all these things is with the things with that were the future expansions that you see into that. So you should be able not only able to understand the underlying application, but also the future of that application. That is going to decide the microcontroller, because then you will choose a microcontroller with some additional functionalities or additional features with it, which can cater you for 5 years, 10 years down the line, without hurting you in the process. And the cost is also again one part, so that also can decide your selection of the microcontroller. So these are very few parts that I just quickly talked about, like selection of the microcontroller, but these are very essential. So this is how you are going to decide your microcontroller and go ahead with it. Then it comes to the IOs. When we are talking about an embedded system, it is majorly about something input, something output, some interface. Some, like say I am going to touch a monitor, and then that monitor, like say display or a mobile monitor, I am touching mobile screen, I am touching, and then it is creating a call for me, or it is creating some, or it is taking a picture of me. So that is where, like say, there are some input sensors mounted there, and then there are something output connected. So and input sensors can be, there are a lot of types of input sensors in the market. I have just picked up a few of them. There can be light sensors. Light sensors can be like photoresistors, photodiodes, proximity light sensors. There are many other types of light sensors as well. Then the temperature sensors, there can be like thermistor, thermocouple, RTDs, semiconductor type of temperature sensors. So there are again the number of sensors available to choose from. It will depend like what sensitivity you need and what range you want to work on. So it will have its own way of filtering. Every sensor you will filter out, and you will decide like which sensor I can go ahead with. So that also will have selection criteria, which temperature sensor you can go ahead, you cannot, which sensor is of no use for you. So you should be very much careful while selecting all these parts. Then there are force or pressure sensors. There are different types of strain gauges are there. Piezoelectric type of pressure sensors are there. Inductive, capacitive, potentiometric. There are different types of pressure sensors are there. Position sensor, there are LVDT, potentiometric again, capacitive, Hall effect sensors, rotary encoders. So these kind of position sensors are also there. So these sensors are based out of some or other physical principles or theories that we have read throughout our curriculum. So these sensor follow some or other physical properties in that. Same like input sensor, there are sensors, there are output connected to the devices. The outputs can be actuators, displays, audio signals. It can be a motor. You can have number of types of motors connected. Yeah, so you can just send something and start your motor. So like say for your washing machine, you press some button and your washing machine starts. It starts the motor, or some LEDs, LCDs displays. So you have LED displays, LCD displays, like say traffic signals. You have this LCD displays put in the every square, which are counting the numbers, counting the time for you, counting the time for you, speakers to put up some alarms or something. So you can have uh, different types of outputs as well. And again, you will have to decide which one you have to go. So every time you should be selecting your input and output with respect to the properties that you want to come up with. The properties, those are expected. So you should be filtering out the number of available choices in the market. So that is about the inputs and outputs. Those inputs and outputs will be comprising of either of this type of sensors and outputs. Moving ahead to the memory part of it. So now we have touched base about the IOs of the microcontroller. Now we are second important part of the microcontroller is the memory. So memory is very vital part. You can see on the left hand side I have put in just register, cache, RAM, ROM, EEPROM, flash. So this I have just sequentially put down, put them up as per the speed of the memory accessing that happens. So registers being the fastest and flash being the slowest of the list. Apart from that, the memory itself is divided in two different sections: volatile memory and non-volatile memory. So volatile memory is like the memory that doesn't retain its data after the power cycle. Non-volatile memory is the memory that retains its data onto it after the power cycle as well. So there are two basic sections into that. And again, it is divided into two separate types as well, as a primary memory and a secondary memory. So in secondary memory, you would see that there are magnetic tapes, magnetic disk, optical disk, CD, DVD. Now those you don't find those CDs and DVDs on your quite often on your mm, laptops and desktops. Now those are also going off the market. Flash memory, you still see that there are memory cards, pen drives. So these are like user mountable memories. So those are like secondary memories are user is going to mount it, remove it, mount it, remove it. So it is just at the time of usage, user is going to handle it. Primary memory is the memory that is integral part of the system. Integral part of the system, which means it is user is not removing it from the system when it is not in use. It is still there in the system. The application is going to decide if I can use it, if I cannot use it, or when I need to use it. So within the primary memory, we can see again there are two sections: volatile memory and non-volatile memory. So in the non-volatile memory, it is non-volatile memory is again called as a main memory. It is ROM, PROM, EEPROM. All types of ROMs are there. And in the primary part, we can see registers and caches, which are very fast, quickest of the all the memory segments. And then main memory, in the main memory we have volatile types of memories like RAM. So ROM is, although non-volatile memory, RAM is again a third fastest memory that is used by the controllers. RAM can have two types again: DRAM, a dynamic RAM, and the static RAM. So basically this is the segregation of the memory. Memory is utilized with respect to its usage. So on the chip, memories are typically utilized by the applications for different configurations, program flashing, like storing some data, application data, and some calculations. So for that, all that purposes, on-chip memories are utilized, and secondary memories are just for backups. You don't run typically you don't run applications through pen drive or a memory card or from CD, DVD. You use it for the data backup, some video, audio contents, some text files, huge text file content backup. So those are typically used for taking the backups of it. And then the primary memories are typically used for different needs of the application. So where main application is flashed or programmed, the main application then after at the time of execution, it starts utilizing EEPROM, it starts utilizing RAM, it starts utilizing registers and cache. So that is how the memory is typically utilized. So this is all about the memory that comes up with the microcontroller, and that can be connected to the microcontroller. So that was it about the memory. So now, so far we have discussed about IOs and memories in the microcontroller. The third very vital part is about the timing requirements. The timer that provides us a tick, and that is where the RTOS comes into picture. So what is an RTOS? What is a RTOS is? Why RTOS is needed? If we know like there is an operating system, why a real-time operating system is needed? So basic difference between the RTOS and the OS is operating systems are just a routine operating system. They just carry out their operations without assuring the timing of the execution. But the real-time operating system will definitely help you to carry out an operations with the timing constraint. So it will carry out a specific work in given time itself. So it is time bound, and it is very much time bound. So that is very much needed when you are working in the real world. You should be constrained to the real time itself. So that is why real time operating systems are into picture. That is where those are needed. So there are different types of there are different types of scheduling mechanisms are available. So in RTOS you can have uh, uh, preemptive scheduling, there are round robin scheduling, then earliest deadlines, first come first serve, priority scheduling. So there are different types of scheduling mechanisms that RTOS supports. Each scheduling has its pros and cons. It again depends upon which RTOS, like say when we will talk about the selection of RTOS, this part will again come into discussion. But then this is again a deciding factor for us to select an RTOS. But preemptive scheduling, when we say preemptive, like it can prevent anything from execution, and it can allow something else to execute. That is what is a vital criteria, a vital feature of an RTOS. So that is a part of RTOS scheduling as well. So there are like say I talked about like 4 or 5 types of scheduling which are prominently used in RTOS, and those are supported by different types of RTOS as per their own algorithms. Again, RTOS helps you synchronization of your work. Synchronization, when I say synchronization of the work, it is like taking this work synchronously. Suppose say 2-3 components are working together. A task is continuously printing some data onto the monitor, and for that, that task needs to have some data to be entered by a data operator. So if someone is entering some characters, and the task is taking those characters and putting it in some memory, and another task is taking up from there and printing it on monitor. Now if suppose say this task is continuously reading to the memory, and then the typing of the data operator is not that much fast, so this sync will not remain. It might happen that the task is running too short, too slow, or too fast, and it is just typing the same characters again, or it is missing some characters. So sync has to be there. So that is what the RTOS is going to give us. If a specific, if a data operator is typing some characters, the task scans those characters, put it that character into memory, and give the signal to the other task which is going to put that data, copy that data and put onto the monitor. So this syncing is handled, or this syncing is facilitated by the RTOS. So this is just a very simple example that I talked about, but there are a number of types of synchronizations. And when we talk about an applications like my mobile phones, it is very complex. So then it comes to the what all tasks and threads and processes. So I just touched base upon tasks when I was talking about the synchronization. Tasks or threads or processes are again the units of the code that is continuously getting executed. You can keep those execution periods, like say for every 10 milliseconds or 100 milliseconds, a specific set of code needs to be executed. It's suppose someone is scanning some input keys from the user, so it is just that the task will continuously uh, scanning those keys, or otherwise it can be kept on interrupt based as well. Typically this kind of application so kept on interrupt based, but the threads keep on executing in that fashion. Though they have their periodicity for execution, they have their priorities for the execution, they have their own memories allocated, and they deal with each other through some or other inter-process communication mechanism that is provided by RTOS. So summarize. So as to summarize it, a task or a thread or a process, they have again different context to talk about. But if we just talk about task, the two tasks are two set of code executing periodically with its own priority, with some memory, their own memory allocated, some own memory for their algorithms to carry out, and with the help of some inter-process communication mechanism that is developed with the help of RTOS. So that is how this whole background is dealt with the help of RTOS. And then the examples of RTOS are again like VxWorks, ECOS, MQX, QNX. There are number of RTOS available in the market. Again, if you go to selection of an RTOS, you also will feel like it's just there is a huge number of RTOS available in the market. Which one I should go? So for that you should be knowing like minimum tech that is required. So again, it is an extension to selection of a microcontroller. Once you have a selection, you have selected your microcontroller, you would be selecting your RTOS. So while selecting your RTOS, again, you should be understanding the complete system through and through. Because that is going to decide the fate of your application. So you should be understanding the complete application. So while selecting an RTOS, you should be knowing like what is the minimum tick that will be required by this application. I need a task that should be executing every 5 milliseconds, every 10 milliseconds, every 100 milliseconds. If this RTOS is providing me the every 10 millisecond tick, if this is providing me 5 millisecond tick, so typically that will be your deciding factor. Types of scheduling we discussed. What type of scheduling it is providing? It is round robin, it is earliest deadline first. So deadline first is like it calculates first like who is going to finish up the task, finish up the work earlier. So whoever is going to finish up the work, the RTOS gives the processor to it, and earliest whoever is going to can finish its own task quickly, that task gets executed, and then the next earlier one is given. So this is how like earlier deadline first is what first in first out is. Again, you know, FIFO, it is just like a FIFO first. FIFO only first come first serve. So whoever comes in first is served first. But round robin is typically majority times use round robin is like the every task is given some time allocated, and that task gets executed for that much amount of time. And it is done by with the help of time slicing. And then the priority scheduling or preemptive kernel is also part of the selection of the RTOS. Footprint of RTOS is very essential. You have to look at it. If suppose say you have only 512 kilobytes of flash, and the RTOS is coming with 300 kilobytes, or say 250 kilobytes of RTOS is coming, it is half of the memory is getting filled up with RTOS. So you should be very selective at the time of the selection. You have to understand like what memory constraints you have. So footprint of RTOS is very much essential to choose from. RAM size, how much RAM that RTOS is going to be utilized. If complete RAM itself is going to get utilized by the RTOS, I'm again out of the memory. When I will start writing my own application, I'll be again out of the memory. So that is also a vital point to be think about. Scalability of the RTOS. Is the RTOS scalable? Because it might happen like RTOS is coming with 50 features, but I just need 10 features out of it. So I should be able to take only those 10 features. I should be able to scale it down. I should be able to remove unwanted part, and then I should be able to just take what I want to go ahead with. So is it scalable? Scalable features are there. What all platforms it is supporting, it is very much important. If a microcontroller I have selected of Freescale and the RTOS itself is not selecting or not supporting the Freescale platform, then you are in a mess. So what all platforms that RTOS is supporting? What all debug features are supported? Because this is, once you go into your complex programming part, debugging becomes very essential and very important part. So if it is providing any debugging features with it, what all types of IPCs I just touched base upon while I was talking about the synchronization. What all type of inter-process communication it is providing? What all types of synchronizations techniques it is providing? So is it providing semaphores, mutex, shared memory, pipes? So there are different types of inter-process communications available. So what all types it is providing to you? And then the last, or maybe like say it depends upon where it comes, but the cost is also a vital part. So decide about or the select the RTOS. So these are again very few part. When you go a realistic approach, you will find still 10 more point to select an RTOS. These were just few quicks I could bring it for you to understand and the importance of selection of microcontroller and an RTOS, how much important that it is.